Welcome to Probability and Statistics. In this lecture video, we're going to talk about chapter 4.4, something called the combinations and permutations. Before I introduce that, I want to talk to you about something called the factorials. So this is a continuation of the very last thing we talked about from the previous lecture video, the way how we count, the fundamental counting principle. Alright, so another way to count, this is another way to do the counting, is something called the factorials. Factorials is given by the following formula called n factorial, which represent whatever the n is, right, times n minus 1 times n minus 2 times n minus 3 down to all the way down to times 2 times 1. So for example, if I have a well, I'm not going to do that one, it's too big. If I have a 5 factorial, okay, by the formula it is saying take your 5 times a minus 1, which is 4. You know, 5 minus 1 is 4, 5 minus 2 is 3, times 2 times 1. You multiply all the way down to times by 1. That's called the 5 factorial. Alright. So rather than typing all this in the graphing calculator, we can type in the number 5 first, then go to math, go under PRB, probability, and choose number 4. So this is called 5 factorial, which if you multiply them up, it will give you 120. Okay? So, evaluate the following expression, 11 factorial over 7 factorial. I'm going to just do this, I'm just going to do this in the calculator. Okay, I don't want to type out all this stuff. So there's a way to type this in where our answer is correct. So what I want the calculator to do is figure out the 11 factorial first, then figure out the 7 factorial next before we divide them. So in that case, I'm going to put my 11 on top in the parenthesis, close it, then divide it by 7 factorial, put that in a separate parenthesis. So now the calculator will do the factorial first before we get divided. 7,920. Okay, so equal to 7920. That would be my answer. Alright, this one is a little bit more challenging because I got 11 factorial on top. So I'm going to just second entry, just copy my 11 factorial. But down here in the bottom though, I actually want the calculator to subtract the 11 minus 3 first. Then do the factorials of the 3 factorial and the 8 factorials. So in the calculator, I need to put a separate set of parentheses. So the outside one is for the entire denominator. The inner one will be the 11 minus 3. So I will open 2 parentheses and say 3 factorial. Open another one for my 11 minus 3. Close it. Then the factorial. The factorial is on the outside right here. And close the parenthesis for the whole denominator. So my answer, 165. Okay. So we can actually use a calculator to do the factorial for us. Alright. Now, how do we, the way how we look at factorial is this, okay? For example, it's a very interesting problem. A doctor visits her patient during morning rounds. In how many ways can the doctor visit the 4 patient during the morning round? So basically what we're saying here is once this doctor visits 1 patient, okay, she doesn't have to, don't have to go back to that same patient during the rounds. So I got 1, 2, 3, 4 patients. Before she goes to the very first patient, she has 4 of them to choose from. And then once she visits one, then the next one she has 3 to choose from. And then 2 to choose from. Then 1 to choose from. So 1 task followed by another task. That means we will multiply. So basically this problem becomes 4 times 3 times 2 times 1, which is the same thing as if we were saying 4 factorial. It's the same thing. Okay, so factorial is another way how we can count. Alright, so 4 factorial. So this problem is basically a factorial problem. So 4 factorial. That means she had 24 different ways she can visit the 4 patient. Alright, that's the way how we think about it. Because the whole idea is once she visit 1 patient, then she only got 3 left to visit, or 2 left to visit, or 1 left to visit. Alright, so let's say we are introducing yourself to 7 different people. So in how many different ways can you introduce yourself to the 7 people? So once you say hello to 1 person, you're not going to go back and say hello again because you already introduced yourself. So this is the same problem. 1, 2, 3, 4, 5, 6, 7. So you got 7 people you can introduce yourself to. Before you go to the very first one, you have 7 to choose from. Once you say hello to that first one, the next one you have 6 to choose from. 5, 4, 3, 2, 1 less person to choose from. So 1 task followed by the other. So this is all going to be multiplying. So 7 times 6 times, so this is basically your formula for factorial. So this is basically a 7 factorial. So in my calculator, 7 factorial. That will tell me I got 5,040 different ways I can introduce myself to these 7 people. Okay, all right, let's call factorials. Now, let's talk about what we so-called a combination and permutation. A combination is referring to a selection of objects from a group without regarding to their arrangement. Permutation is also a selection of objects from a group where the arrangement is specific. Alright, so the formula says when the order is not important, when the order of arrangement is not important, then we can use something called combination, which is abbreviated for NCR. The capital letter N stands for N distinct objects. Okay, R is so many we're gonna select from the group. So we got so many we choose from. Okay, we got so many objects, choosing all of them using combination. Alright, permutation is where order is important. Okay, so we got N distinct objects, choosing all of them using permutation. So what does it mean when the order is not important or the order is important? What does that really mean? Well, let's put it this way. Okay, let's say, for example, John and Jang going to Disney World. Curious about Disney World. Alright, let's say John and Jang going to Disney World. Okay, that's it. Just John and Jang go to Disney World. So, if I pick John first, then I pick Jang, versus if I pick Jang first, then John. Is this 1 way or 2 ways? If I just want to pick these 2 people to go to the Disney World, is this referring to as 1 way or 2 ways? This is actually, most people would think this is actually 1 way because this is actually exactly the same 2 people. And you're correct. It doesn't matter who I pick first. Both of them are going to the Disney World. This is actually 1 way. Okay, even though I can write as 2 different things, this is actually the same thing. Okay, so this is where the order does not matter. The order is not important who I pick first. Now, if I give you the same example, Zhang and Jan go into Disney World, and whoever I pick first who is picked first will drive. Well, now this order actually matters who I pick first, because the first person I pick got to be the one that's driving down to the Disney World. So now this is actually two different ways. So that means this becomes a permutation. Permutation is where the order is actually important, who I pick first, second, and third. Versus combination is doesn't really matter who I pick first. Okay, where the order is not important. Alright. Just a quick example. Alright, let's put this let's practice how to type this in. Okay, so this is 10 objects, choosing 6 of them using permutation. So in the calculator, we will type in 10 first, go to math, go under PRB and choose number 2, MPR. Okay, 10 choosing odd of them, which is 6 using permutation. Press enter. So that will actually give you 151,200. Okay, that will be that many ways. Alright, while I'm at it, I'm going to do a 10 choosing 6 using combination. And you can see the difference in answer. Also in 210 ways. So permutation, when the order actually matters, okay, same numerical value actually is a lot more ways compared to using a combination. Okay. Alright, let's try this one. Okay, same thing as the factorial. I want my calculator to do the 10 choosing 7 first using combination. So I'm going to put it in the parentheses just to be on the safe side. So NCR is number 3, choosing 7, close it, divided by, open the parenthesis for my permutation, 10, choosing 5, using permutation. So that will be, it shouldn't be that, MPR 5. Maybe it is right. Yeah, because both of these will be a numerical number. It doesn't quite. No, it shouldn't be like that because I'm dividing. Maybe it will. Let me take away. Let me just retype it. Did I type in something wrong? The answer look kind of odd for me. Alright, so I'm going to do it separately. 10 choosing 7 is 120. 120 divided by 10 choosing 5. 120 over, yeah, so that's right. 120 over that. Okay, so it is correct. So simplify, make as a fraction, that's 1 over 252. 1 over 252. Okay. So nothing is wrong. Everything is good. Alright, so we did typing alright. Alright, 8 choosing 3. So 8 combination, choosing 3 of them. That will be 56 ways. Okay. Alright, so let's try some examples. Okay, so you and I can so I can show you how to distinguish between permutation and combination. So counting is very confusing because it depends on the problem. Some of these can get quite complicated. So as we read these problems, read the following problem, you got to think about, okay, you know, is a permutation combination fundamental counting rules or that factorial thing. By the way, just so you know, when we did this 7 factorial right here, okay, this problem, factorial problem, is actually almost it's actually the same thing as if I would say 7 factorial is same thing as 7 choosing 7 using permutation. Okay, because the order matters. Which one I go see first, which one I go see second, because once I introduce myself to one person, I'm not gonna go back to introduce myself to that same person again. So which one I choose first does matters. It does actually matters. So 7 choosing 7 using a permutation is actually the same thing as 7 factorial. Okay. ways. Okay, so 7 choosing 7 of using permutation is the same as a 7 factorial. So right away, as you can see, there are 2 different ways of thinking about this same problem, and that causes some confusion from time to time. Sometimes you will watch me writing down this way, almost like I'm writing it as a fundamental counting principle. Okay, sometimes you will see me do permutation way or combination way, so it does kind of get confusing. It really depends on the problem itself. Okay, so let's just give a try. So let's say a newly elected president need to decide remaining 6 spots available in the cabinet he or she is appointing. So I got 6 spots. There are 12 eligible candidates for these positions, where the ranking matters. Right there, who I choose first matters. Okay, how many different ways can the member of the cabinet be appointed? So when the ranking matters, that means when the order matters, I'm using a permutation. So there are 12 I can choose from. Okay, using permutation, because the order matters, I'm only going to choose 6 of them, and that is basically the same thing as saying, okay, watch this, I got 6 spots, 1 2 3 4 5 6 spots. Before I choose anybody, the first position I choose, I have 12 people to choose from. Once I choose one, then I got 11 to choose from, 10 to choose from, 9 to choose from, 8 to choose from, 7 to choose from. So one task followed by the other task. So I will multiply. So if I will do it this way, 12 times 11 times 10 times 9 times 8 times 7, give me that answer, which is the same thing as if I would say 12 choosing 6 using permutation. It's the same answer. 665280. Okay, if I will have this many ways I can choose. Alright. So sometimes you will see me do it this way, sometimes you'll see me just write it as a permutation. Okay. Alright, let's say a coordinator will select 8 songs from a list of 9 songs to compose an event's musical entertainment lineup. How many different lineups are possible? So I got 9 songs, I need to choose 8 of them. Does the order which one I play first, second, third matters? Okay. Does the order of who I choose first, second, and third matters? If it does not matter, okay. If it does not matter, then it's combination. If it does matter, it will be permutation. Which one do you think? Does the order of which song I play first matters? Actually, it does matter. It actually matters which song you want to play first, because most of the time when people do these musical entertainments or concert, they actually already pre-selecting which song the group of song they're gonna play, and which one they're gonna play first, second, and which one they're gonna play last. So the order actually matters. They don't just randomly just saying, "Oh man, I got 9 songs. I'm gonna just randomly select which song I want to play first." They actually already pre-planned all this. So selecting songs here actually where the order matters. Which song go first, which one goes second. Because you don't want to play a popular song first. You want to play popular song first, popular song in the middle, another popular song at the end, to keep people interested. So this is going to be 9 songs, choosing 8 of them using permutation. So 9 choosing 8 using permutation. That will be that many ways. 3, 6, 2, 2, 2, 8, 8, 0. So that's 362,880 different ways we can have these lineup. Different lineup of songs. Okay. So if you really think about it, a group of 9 songs, if you just pick 3 songs, 3 different songs, 1, 2, 3. Okay, if you pick 3 different songs, let me use letters. Song A, song B, song C. Is that the same lineup as if I would pick song C, song A, and song B? This is actually a different lineup of songs. Which one's being played first, second, and the third? Okay, so the order does matter. All right. Now the next one is quite difficult. Let's say we are getting a lineup ready for school kickball game. Okay, we got 5 girls and 5 boys. So when you see this lineup, this is just like this is a lineup of my song. So the order does matter. The rule states each child must kick the same number of times and alternate girl boy or boy girl. Ooh, that makes it interesting. Okay, so how many ways can the lineup be made for 1 round? So hang on a second. Alright, so how many ways are possible? If I do girl boy lineup, okay, if I do girl boy, alright, so there's a girl first, boy, and a girl next, and a boy. Okay, but this word "or" means basically what I got myself is let me say this way. I got girl boy lined up, or I can use a boy and a girl way. So that's already 2 different tasks of alternation here. And then I have 5 girls and 5 boys. So if we just focus on one of these, okay, if I focus on one of these, all right, girls, I got 5 girls to choose from. Okay, I got 5 girls to choose from. Does the order which 5 girls kick first matters? Of course it does. If you're a girl, of course you want to kick first. Okay, you know what I'm saying? So just the 5 girls alone, which one go first, second, and third already matters. So that tells me that there's gonna be 5 girls choosing all 5 of them, because everybody got to kick the same number of times. So everybody got to kick. So this is already the girl, okay? But I also got 5 boys involved too. So all 5 boys will actually kick as well. So within the girl-boy alternation, I have 5 girls choosing all 5 of them. I'm also gonna have 5 boys. I'm also gonna have 5 boys, and all 5 of them got to kick. So the girls followed by boys, one text followed by the other, we will multiply. Okay. The word or, as you can recall, means adding. So rather than add up both of these, oops, hold on a minute, let me move this away. Alright, so this right here is the girl-boy lineup. But once I figure this out, I can just add a certain amount of number that will give me the boy-girl lineup. So rather than add, here we can actually, once I figure out the lineup for one way, I can just multiply it by 2, because I got 2 different alternative here. Alright, so I times 2 because I got the other method, boy kick first, then girls. So 5 choosing 5 using permutation. Okay, because the permutation, because which girl kick first matters, which boy kick first matters. That's why it's permutation. Times 5 choosing 5, close parenthesis, and then times by 2. So I got 28,800 different lined up I can choose from. Okay. Alright, so let me just highlight this real quick, okay? This is how many ways the 5 girl can kick, followed by this is how many ways 5 boys can kick. Okay, and this one is girl first, boy next. But I also got another way, which is boy first, then the girl next. So I got 2 different ways. That's why I times by the 2. Okay, kind of weird. Alright, let's try another one. Let's say 4 cards are drawn from a standard deck of 52 cards. So I'm going to draw 4 cards from 52 cards. How many different 4-card hands are possible if the drawing is done without replacement? Okay, so I'm going to draw 4 cards and I'm not going to put it back. Okay, so let's pretend. Okay. Let me see if I get some deck of cards. Alright, so here's my deck of cards right here, okay? So let's say this is 1, this is 2, this is 3, and this is 4. Okay, so as you can see, I got Jack, 10, 7, 5. That was the order I just presented. What difference does it make if I would pick 10 first, 7 next, Jack, then 5? It's actually the same 4 cards. Compare that to if I will have 5 first, 7 next, 10 next, then the Jack. Is that still the same 4 cards? In other words, does the order matters? Which one of these cards come first? The answer is no. It's still the same 4 cards. Okay, if we want to play the game of drawing 4 cards. So, since the order does not matter, then this problem will become combination. 52 cards to choose from, and we're going to choose 4 of them using combination. So how many hands, how many different 4 cards hands are possible? 52, choosing using combination 4 of them. So 4 card draw, you got 270,725 different ways. Okay. Now, most of the time when we play poker, it's a 5-card draw. So if you do 52, choosing 5, and because which card comes first does not really matter if it's a regular 5-card draw. So that will give you this many hands that are possible. Okay. All right. The next example, real interesting. Alright, so let's say there are 16 people in an office with 3 different phone lines. All the 3 lines begin to ring at once. How many groups of 3 people can answer these lines? So I got 16 people. How many groups of 3s people can answer these lines? Does the order of which line being answered first matters? Not really, because they all ring at once. So this got to be a combination where I got 16 people to choose from. Okay, using combination, choosing 3 of them to answer these 3 lines. Okay, they all ring at once. It doesn't really matter which one I pick up first, because all 3 of them got to pick up. Each one got to pick up 1 line. So 16 choosing 3. So that means there are 560 groups of 3 people can answer these 3 phones. Okay. Alright, so hopefully we understand a little bit better about combination and permutation. Alright, let's try some more, okay? This is an interesting one. So let's say we got to have a password. Okay, this is very common. With 6 letters followed by 3 odd digits between 0 and 9. Inclusive. Okay. Alright. If the character and digits cannot be used more than once. So that means once I pick a letter, okay, I cannot repick again. How many choices do you have for your password? Alright, so problem like this right now, I'm not quite sure, don't really quite sure how does the order matter or doesn't matter comes in yet. The first thing we got to understand about this problem is the password gonna have 6 letters and followed by 3 odd digits. So I'm gonna have letters and followed by 3 odd digits, or digits, just digits. Okay, so it seems like there's 2 tests, but there's actually more than 2 tests because the letters alone I'm gonna pick 6 of them. 1, 2, 3, 4, 5, 6, followed by 3 digits. 1, 2, 3. Okay, so how many letters? So before I pick the first letter, how many can I choose from? 26. The problem says cannot reuse this, cannot use the letters and digit more than once. So the next letter I only got 25 to choose from. The next one 24 to choose from. Okay. 23 to choose from. 22 to choose from. And 21 to choose from. There you go. So that to me sounds like 26 letters choosing what? 6 of them. Followed by, so we multiply again. This is one test followed by the other. So all this is going to be multiplication. Alright, this part is a little bit trickier. 3 odd digits between 0 and 9 inclusive. 0 and 9 inclusive. So odd digits. How many odd digits? How many odd digits between 0 and 9? 0, 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, 9. Odd digits. Odd digits. 1, 3, 5, 7. That's 4, but 9 is also an odd digit between 0 and 9 inclusive. So that's 1, 2, 3, 4, 5. So I got 5 odd digits to choose from. So that means the first odd digit I got 5 to choose from. The next one I only got 4 to choose from. The next one I can choose what? The remaining 3. So one digit followed by the other. We will multiply them again. So this problem is basically saying we just multiply all this stuff, or we can see it as what? 26 letters choosing, okay, 6 of them using permutation, okay, because the order actually matters which one I choose first, because once I choose it, the next one will be a different one. Okay, the next letters will be a different one I choose from, because I'm not going to go back reuse the same letter again. Just like the meeting the 7 people, you're not going to, once you say hello to one, you're not going to go back again. So that eventually become a factorial problem or a permutation problem. So they're all kind of very much related in a way. Times 5 odd digits to choose from using permutation again. I'm choosing 3 of them. Alright, 26 permutation 6 times 5 choosing 3 using permutation again. That would be that many. If I were to type out all these stuff I just wrote, 24, 23, 22, 21 times 5 times 4 times 3. We get the same thing. Okay, so there will be that many ways we can actually have a password. So it'll be 9, 945, 936, 000. That many ways. So this is what? Oh Lord, that's a million, billion, trillion, 9 trillion, not almost 10 trillion ways, basically. So that's the reason why it's very, very hard to crack passwords and codes. Okay. All right, interesting. Oh, this is a cool problem. How many ways can Rudy choose 5 pieces of topping from a menu of 6 toppings if each topping can only be chosen once? There was one thing I never talked about, is where combination and permutation, the repetition is really not allowed. So you cannot reuse the same thing that you already used. And that makes sense, right? I mean, you're choosing 5 toppings. You know, once you choose, I mean, if you want to choose 5 different toppings, why would you choose the same topping you already chosen? Gotta be, you know what I'm saying? It gotta be 5 different toppings. I'm gonna choose from 6 of them. Does it really matter which one I choose first? So, if I want to do sausage, if I want my topping to be sausage, pepperoni, mushroom, I like mushroom, pepper, onion. Okay, does which one I choose first, or does which one they put first on the pizza matters? Not really, because once you baked it's all together anyway. You can't really distinguish from, when you look at your pizza that's cooked, you cannot really distinguish between which one is put on there first. So the order of which 5 I choose does not really matter. So this is a combination. 6 toppings, choosing 5 of them. So that will actually give me 6. There's only 6 ways I can do this. Okay, 6 ways we can choose the toppings. All right. This is a very interesting problem. And we can change these numbers up. A person tossed a coin 22 times. In how many ways can he get 16 heads? In how many ways he can get 16 heads? Okay, so I'm not gonna write all this out. I'm gonna say 1, 2, 3, 4, 5, 6, 7, ... And then I'm gonna say, 1, 2. All right, so the last one. Okay, so this is a 22. There are 22 head tossing the coin 22 times. So this last one is your 22nd toss. All right, so out of all these 22nd toss, there's gonna be 16 heads. So let's pretend that the second one is a head. The next, the fourth one is a head. So altogether there are 16 heads. Does the order which head come first matters? Not really, because heads is a head. The first one is the first one. Watch this now. Just use the first 4 for example. Does this head come first matters compared to that head? Tell. What happens if this head comes first and this head comes second? This is exactly the same thing, isn't it? Because you cannot really distinguish between this head to that head. So that tells you that the order which head comes first does not matter. So that means what? This is a combination problem. So toss it 22 times, choosing 16 heads. 22 choosing 16. That will tell me how many ways I can have 16 heads. 74,613. Okay, so let me just do another example with you. I'm gonna just copy the exact same thing. Okay, I'm only gonna toss it 3 times. Okay. Now I'm gonna try to get 2 heads. So let me show you how this thing actually works when we actually count them. 1, 2, 3 toss, for example. What could I have? I want 2 heads. Remember, I want 2 heads. So my 2 heads, could it be head first, next one is not head, the third one is head? That is one way. What else could I have? What else could I have? Excuse me. 2 heads. Where else can I put my 2 heads? How about I put a head right here and a head right here? So that's another way. So these 2 ways are different. What else could I have? How about my head right here and the head at the end of the third toss? That's another way. So you can, as you can see, okay, which head is which head comes first does not matter. But in terms of the ways the 2 head can be placed, okay, these are what, 3 different ways already. So if I want to toss the coin 3 times, choosing 2 heads, 3 choosing 2. That will actually tell me, oops, sorry. That will actually give me 6 different ways I can choose from. So there are 3 other ones I have not listed. Okay, of course. I just want to give an example of actually looking at this. How many ways we can put 2 heads. Alright. Now the last question is actually quite interesting here. I like this problem. Let's say we're ordering a hamburger. And we can tell them, to put, we can have up to 8 toppings. No matter what kind of topping it is. But each topping can only be used once. And you tell the cashier to surprise you with the topping you get. Okay, you can get up to 8 toppings. What does that mean? Up to 8 toppings. That means you can have at most 8 different toppings. So what's the probability that you will get 4 toppings? So this is a probability problem. What's the probability of getting 4 toppings? Alright, so let's think about this for a minute, okay? I can have up to 8 toppings, so can I have 0 toppings? Sure I can. Just buns. Okay? I can have 0 toppings. I can have 1 topping, 2 topping, 3 topping, 6 toppings, 7 topping, or I can have all 8 toppings. Okay, this is a very important question. So these are the possible scenarios of toppings I can have. The problem wants me to find what's the probability of getting just 4 toppings, which is right here. So that tells me that how many ways I can get 4 toppings. So that would be 8 toppings to choose from. And this time we're going to choose 4 toppings. So that will be 8 choosing 4. But the denominator is actually much, much harder because the denominator is the total number of ways, okay, I can get up to 8 toppings. 4 is just only one of these ways. Oh, excuse me, 4 topping is just one of these scenarios, one of the 8 scenarios. So one of the scenario can be, oh, excuse me, I forgot one of the most important ones, 0. I can actually choose 0 toppings. You know what I'm saying? No lettuce, onion, tomatoes, just ketchup. Okay, or nothing, just the buns and a burger. Alright, so this problem kind of being repetitive here for real quick. My scenario. Okay, my scenario, 8 of them, topping choose from. I could choose 0 topping. Followed by, oh, excuse me, or, it's a word or because I can do 0 topping or 1 or 2 or 3. So that means we will add. Or I can do 8 toppings, choosing, I'm not gonna typing NC, I'm gonna typing C. Choosing 1 of them plus 8, choosing 2 plus 8 toppings, choosing 3 of them plus I can have 8 toppings, choosing 4 of them, or I can have 8 toppings, choosing 5 of them, or 8 topping, choosing 6, or 8 topping, choosing 7, or 8 topping, choosing all 8 of them. There's 8 topping to choose from, choosing all 8 of them. That got to be only one way. Okay. 8 toppings, choosing none of them. So let's do this one at a time. Okay. I'm gonna write it down here if I can. All right. So 8 topping, choosing none of them. That's one way, so that makes sense. That's only one way. Plus second entry, choosing 1, so that's 8 ways. Plus 8 choosing 2. $28. 8 topping, choosing 3 of them. How many ways? 56. 8 choosing 4. 70. This is 70 up here already. Plus 8 choosing 5. So I'm gonna say plus now. Oh no, never mind. No, never mind. I'm gonna just write down one by one. 56. Ooh. No surprise what the next one gonna be. I bet it's gonna be 28. Choosing 6 of them. Yep. So as you can see, 8 choosing 7 toppings gotta be 8. And 8 choosing 8 gotta be 1. Alright, so this problem, let me put the stories up top. Oops, maybe I should have done that. So this problem just now becomes 70 ways. 8 choosing 4 is 70 ways I can choose. This thing is messing up. Right, denominator 1 plus 8 plus 28 plus 56 plus 70 plus 56 plus 28 plus 8 plus 1. 256. So there's 70 ways to choose 4 of them out of 256 total possible outcome. So if I reduce my fraction, so my probability is about 27.3%, 2.734, or if I do as a fraction answer, that will be 35 out of 128. Okay. Alrighty. So hopefully after this section, after this lecture video, you can have a little bit of basic understanding of how combination, permutation, fundamental accounting principle actually work, okay, in terms of probability. Alrighty, so we will conclude our lecture video here. Thank you for watching.